Person A works in an administration office. He faces a trial involving administrative misconduct because he bullied the victim, and the victim is Y. He sent false bills to the victim, so the person in the administration office, and wanted the victim to pay without a real obligation. And the victim files a suit, and during the trial, both persons make statements. Hello universe, this is Zahra M.M.A. Sadiq. Legal AI connects AI and law. The AI algorithm connects multiple legal cases or arguments, compares them, and finds a pattern. It uses this pattern to create legal clauses and to apply them like a lawyer. Back to our case. The first person is the victim Y, and Y says that the administrative employee A committed the breach of law, and A of course says that he did not breach the law, and A also states that his boss told him to act the way he did, so he did not feel responsible for his action. So one person says P, and the other person says not P and Q. And obviously between P and not P there is a contradiction. And this is the usual constellation in a trial. When argument cannot be right and wrong at the same time. In the world of binary logic, this might not be possible. If the truth value of P is 1, the truth value of not P, the opposite, is automatically 0, because there are only 1 and 0. If the evidence supports P, not P is false. We know this for sure, but B also stated Q, and Q is the game changer. It is the joker that could save A. Q is an argument that supports one of both opinions, and it contains additional information. In this case, A additionally states that his boss told him to act the way he did. This argument is important because the boss could be the perpetrator, but A knew that his behavior could result or would result in bullying the victim, and he was responsible for his actions if he knew that the bills were false. This would have been different if A didn't have any knowledge. If A, for example, didn't know that there was no obligation to pay those bills. If his boss had given him a writing for Y and had said that the payment rule is justified, this might be important because maybe A didn't have the possibility to recognize that it was a fraud and that there was no obligation, and he thought he's justified. According to the evidence, A was not trustful, so both were involved. Let's solve this contradiction between P and not P, or between guilty and not guilty, by using ternary logic. In this case of ternary logic, if we know that not Q is true, this does not automatically mean that Q is 0. So it can also be 2. We have 3 truth values, 0, 1 and 2. If not Q is the best argument because of the evidence, the truth value is 2. If it is worse than Q, the truth value is 0. Y states P and A states not P and Q. This is the ternary AND operation for the contradiction. In a ternary setting, the truth value is 0 if one of the inputs is 0. If the truth value of Y statement that A committed the fraud and A statement that he did not commit the fraud is 1, and if the truth value of the statement that his boss forced him to commit it is 2, the entire statement is also 1. And now we solve P and not P. This is the OR operation. If Y statement that A committed the fraud is 1, and a statement that he did not commit the fraud is 0, the entire statement is true. True means 1 in this case, and if Y statement that A committed the fraud is 2, and A statement that he did not commit the fraud is 0 or 1, the entire statement P or not P is true. This form of reasoning is also used in the realm of nanocomputing and molecular computing. Usually, nanocomputers and molecular computers process chemical, biochemical, and physical inputs.